Hello, I'm Mr. Kinduri, a physics teacher. Welcome to our ETETA program in collaboration with the Pixel International. Today, we are going to learn how to answer questions which appear in National Examination Council of Tanzania properly. So today we are going to see question number 11, which was given by NECTA in the year 2020, question number 11. In question 11, first of all, we're asked to describe the mechanism of doping intrinsic semiconductors to obtain P-type semiconductor. That was part A. Part B, you are required to explain why most of the transistors in use are NPN transistor. And part C, there is this question that there is Form 1 students were shouting in their classes. We are required to explain briefly how other students in the next room or in the next class can hear them shouting. So we are going to see how we can answer this question properly. So first of all, we are going to answer part A. In part A, we are required to describe the mechanism of doping intrinsic semiconductors to obtain P-type semiconductor. In this question, first of all, you are supposed to understand what is doping, this terminology, which is very important. Also, what is intrinsic semiconductors. After knowing what is the meaning of doping in intrinsic semiconductors, you will be able to explain the mechanism of doping in P-type semiconductor. Also, you are supposed to know what is P-type semiconductor. So, first of all, let us explain about the meaning of doping. Here, doping in intrinsic semiconductor refers to the process, just a process, of adding impurities in semiconductors in order to modify its conductivity. Or shortly, for the purpose of modulating its electrical, optical, and structure property. So simply, doping is a process of adding impurities to pure semiconductors. Those pure semiconductors, sometimes we may call it intrinsic semiconductors. So after knowing the meaning of doping, then we can explain the mechanism of obtaining P-type semiconductor from pure semiconductors or intrinsic semiconductors. During the process of doping intrinsic semiconductors, during the process of doping intrinsic semiconductors, these are pure semiconductors. These are group 4 elements to get P-type semiconductors. The impurities which are supposed to be added, to intrinsic semiconductors or to pure semiconductors are from trivalent impurities, or we can say that trivalent group or trivalent elements. Examples of trivalent elements are aluminium, boron, and indium are good examples of group 3 element or trivalent impurities. So aluminium, boron, and indium are good examples of impurities. When it is added, when you take group 3 element and add it to the pure semiconductors or intrinsic semiconductors, is the point where you can get P-type semiconductor. When intrinsic semiconductor is being doped by trivalent group like aluminium, boron, or indium, it leads to the formation of what? Holes. Due to one atom added to complete the doping process. This trivalent element like aluminium, boron, and indium, has 3 electrons in outermost shells. And pure semiconductors or intrinsic semiconductors in outermost shells, they have 4 electrons. So it remains 1 electrons in order to fill the gap. So this gap, we call it what? A hole. And the resulting type of semiconductor is known as P-type. P means positive, and the positive stand for holes. So this is how you can describe the mechanism of doping. Simply, you take intrinsic semiconductor doped with trivalent group such as aluminium, boron, or indium. In part B, we are going to answer this question: why most of the transistors in use are NPN transistor? Because we have NPN transistor and PNP transistor. So why in most cases we use NPNP transistor instead of PNP? The answer will be like this one. Most of the transistors are used in our daily life, which are NPN transistor, because of it is consists of electron as majority charge carrier. In NPN, majority charge carriers are electron rather than what? Holes. So we prefer to use NPN transistor because of this property of having majority charge carriers are electrons. In PNP, majority charge carriers are holes. That's why we are not used in our daily, we are not used mostly in our daily uses. This is how we can answer this in part B. Let us now go to the part C. So as you can see here, first, the mobility of the electron is higher than the mobility of the holes. In part C, we have said that there's a Form 1 student were shouting in their classroom. We are required to explain how other students which are found in other classes can hear them shouting. This question, it does not belong to, in electronics as a topic, it belongs to wave. Here, the examiner wants you to understand the behavior of wave, especially sound, when it meets with obstacles. One among the properties of sound when it meets with obstacle is diffraction. Diffraction is one among the behavior of sound wave. So the student in other room can hear them shouting due to the diffraction of sound waves. This word diffractions is the behavior or tendency of sound when it meets with the block, tend to be diffracted. So first of all, we have to understand what is diffraction. As I said, that diffraction is just a phenomena shown by or occur when a wave encounter an obstacle or sometimes opening. So when sound wave meet an obstacle like a wall, as we know that the class are made up of walls. So when sound waves, when these Form 1 students are shouting, sound waves meet an obstacle, which is the whole wall of the class. They tend to vibrate or revolve around the obstacles. Being so, other students can hear the sound because of the sound wave rotate around the wall. So the sound, the shouting sound, go to the wall and bounce. Then the sound will reach to the other classes as if it is originated into their rooms. So that is why the other students which are in the next class can hear shouting from the Form 1 student who are shouting in their class. That is all about. Thank you for to be with me to these questions. See you next time.